Hello. In this video, I'd like to show what I've made, the progress of my WebAssembly plugin, and I'd like to also make this be a tutorial about WebAssembly and how to write raw assembly code inside of the game and see what's going on inside of the game. So to get started, we will need a protoflux tool and a dev tool. First, I'm going to create a new empty object like this, and I'm gonna need some components on here. First of all, the plugin supports binary modules, but it is, since I want to show how to write WebAssembly, it may make more sense to actually write assembly code in the game. For that, we can use the text WebAssembly module. It provides a text input and an error output. So yeah, if you feel like it, you could even make like a WebAssembly text editor that also is more like an IDE that shows you, where you made an error, for example. It will give you error messages. And to make writing this a bit easier, I've prepared an asset in my inventory. It's under here. This is just a text editor, but it gives me this reference, and I can just drag this into here, and I can drive it. So now this will say hello world. Currently, the error will only show if you actually use this module. So I'm just gonna wait, I need to switch tools here. I want this to be a source because I want to see the error while I'm working on it. So I'm just gonna do this. Okay, that should be good enough for an error. And to actually see error messages, we will need to import the module somewhere because this is lazily loaded. For that, I'm gonna create a WebAssembly instance, and I'm gonna drag this module into here. And now we have an actual error. It looks a bit weird, but that's because of the formatting. Expected an opening brace or bracket or whatever you call it. Let me just get my oh yeah, it was here. I need a reference, otherwise it will be hard to show. I'm well prepared. Okay, so to get started, I'm gonna do it like this so that you can see the error output. We want to declare a module. Oops. Yes, I cannot press enter. We want a module. And in that module, we want to define a function. For that, we need to give it a label. In this case, let's say we want, yeah, my previous example works as well. I call it, okay, I'll just call it add. We'll make a simple addition. And the addition needs parameters. We have a parameter, let's call it a, which is an integer. The i32 stands for 32-bit integer. We need a second parameter, which is also going to be this. And we have a result. Let me put that on a new line. Result of i32. Okay. I'm gonna need to end the function. Okay. Here you can see that it complains because it couldn't compile the module, and that's because, well, it's already showing you type mismatch, expected i32, but nothing on the stack. That's because WebAssembly is a stack-based language. It works by pushing and popping values onto a stack and onto and from a stack, whatever. So to push values on a stack, I'm gonna need to load a local, for example. And our parameters are loaded as locals. So I can load this, and now it doesn't complain anymore. It compiled. it doesn't add anything, it just returns a, in this case, the first parameter, but it did compile. So this module, it works. I just want to show you how you can actually see that it is working. And for that purpose, I'm gonna need a protoflux node. We have the WebAssembly protoflux nodes. Get export and load file, those are for development purposes mostly. Get export just gives you more insight into what exports a module has, but I'm still working on that part. But in this case, we have actions and we have functions. Functions are just like actions, but you don't need an impulse to evaluate them. Actions are more intended for things that have side effects, and like side effects like modifying the state of the module itself or something like that, or interacting with the world maybe even. But we want a function, and to get a function, we are going to get the instance. Okay. Yeah, I declared a function. That's nice and all, but this doesn't mean that I have access to it outside of the module itself. We can call this function within the module, but that's it. Awesome. Okay. I'm just going slightly insane. Let me just drive this again. Okay, to get exports, because these exports are supposed to just show up immediately. Once you declare them, you have to declare them. Here. To export something, we write export, and we write the name. Let's say we call it add. And then we want to export a function. So we just say we want to export function add. Like this. And that, oops. I didn't mean to press enter like that. Yes. Okay. Awesome. No error. And what do you see? It's add. Okay. Function. Item. Put it in here. And there we have our two parameters. I don't get the names because this module is actually compiled to a binary and has not this metadata, so I cannot be fancy. But what I can do is I can supply inputs and outputs. The only disadvantage of WebAssembly functions is, because they don't integrate that much into the game, that they cannot declare that, for example, they're continuously changing or stuff like that. Which means that the output value only changes when you change the inputs. So if you have any stateful nodes, for example, then you will need a continuous relay. The same goes for if you actually modify the module that the function of the function. Like when I start editing this node also won't update itself. But because I want to show that off, I'm just gonna put in a continuation relay, which you can find here. Continuous changing relay, whatever. This just tells protoflux that this value needs to be re-evaluated every update. Okay, so let me put this here. Also, one caveat of the plugin currently, and that can only be fixed by mods, is this wire will be invisible. That's just a design limitation at the moment. Okay, so we have add. The second number is completely ignored right now, so I can put 42 in here, nothing will happen, but we're just returning the first parameter, and this is what's happening. Actually, I want 42 to be returned later. So we are gonna modify this module, and we are going to load other local, and we are going to call add. Oh, what do you see there? It immediately updated, and now we have 42 in here. This is nice and all, but here's the big flex, because most programming languages don't support, at least don't natively support, returning multiple values from a function or method or whatever it's called in that language. Most languages rely on things like returning a tuple or whatever other type that contains the values. WebAssembly works differently. WebAssembly actually natively supports, it's called multi-value. That's the proposal, the standard proposal they implemented. So I'm gonna make another function to showcase this. I'm gonna call it, wrong name, addmul, because I wanted to do two things at once. It's gonna have parameter a. Actually, let's work with different types. That will be a long type in the game. Okay. Then, as a result, we will of course have the same type. Then let's end that one. Okay. We get our first locale, then local, whatever. We get the second one, i64.add. Okay, doesn't complain. But now here's the cool part. I'm gonna add another return type. Now it's still gonna complain because we need to return something else. And I'm just gonna load the locals again. I need to scroll just a second. Okay. Yes. Okay. And multiply. Okay. And oh, before I forget it. Mistakes have been made before. We're gonna need to export it. So I'm just gonna export addmul. Keyboard. Like this. And there it is. Addmul. Let's get one of these. Actually, I don't need that one. Addmul. You can also see that on the proxy, you can see the inputs and outputs. There we go. And you can see these are long values. Okay, I'm gonna put 1000 and let's say 35. And you see, first values were added, second values were, second output it was multiplied. This can be very powerful, especially later when I want to add data model access, where the WebAssembly module would be able to write to fields, for example. Maybe. I'm still not sure what I want to implement, but I want to do some basic stuff like slots, adding, removing slots, renaming them. The stuff that you can also do using Protoflux, but inside of WebAssembly so that you can actually use a programming language that's not Protoflux to do stuff. And it's also going to be faster. So if you have some mathematical algorithm, you can implement it inside of Protoflux, inside of some programming language that can compile to WebAssembly. We didn't even use memory or globals or all the other cool features that WebAssembly has. It can also do multi-threading, so you can make multi-threaded programs and just interact with those using Protoflux directly. There's a lot of cool stuff that I still want to do with this. I'm just extremely happy that it is actually working right now and it is working this well. uh, so yeah, you can write modules like this, which for basic stuff can be useful. For example, you could put the Quake fast inverse square root algorithm in here as WebAssembly, which would be kind of cool if people want to, I don't know, do whatever they want with that. In the future, I also want to support dynamic assets, or rather procedural assets, using WebAssembly so that you can make whatever, like custom geometries, like geometry nodes inside of Protoflux. Well, not Protoflux in that case. Geometry nodes inside of Resonite. That would be awesome. But anyways, this is all I wanted to show today. There will be more progress in the future.